All right. I just saw that one very important section is missing from the tutorial. So I want to add this because this is really, really critical in how you deal with linear mixed effect models. So, and this is the interpretation of the model output. So if we run a model, like, for example, attractiveness 2, then it gives us a bunch of output, and it's very important to know what to look for. The model, the criterion at convergence, as long as the model converges, is something not to worry about too much. This is more like when you do very specific things and simulate ideal models of very complicated data sets. The random effects are also not so interesting because, well, technically you're not interested in them, right? But the fixed effects are the part you really have to pay attention to. And here you get a table with a bunch of information. And the most ignored, but actually most important line of this whole output is the first. And this is the random intercept. So the random intercept is if you just randomly bootstrap data from this, you get an average rating of attractiveness of almost 8. And each of these factors, which then contributes to the model, is listed underneath. And this is the beta value of the random intercept. And each of the factors adds variance explained in the beta value in relation to this. So this is your effect size, so to say, only in comparison to this. So if you have a random rating from 7.88 and de facto vowel front without taking anything else into account, changes this intercept for front vowels for minus 0.13, and for back vowels it raises this. So whether this is significant or not, this is the intercept for now. And here, for example, in the interaction, you see this is the interaction line, and there you see that the beta value is actually almost 0.3. So this means that this interaction has an effect size of 0.3 compared to this value. The standard error is here in this column. It's important to see like how noisy your data is. And then the t-value gives you the first indication of what might be significant and what not. So yeah, this is how you read this table. And please never, never ignore this first line. And when I submit manuscripts, I often get the comments that people don't understand how to interpret the effect size. And as effect sizes in linear mixed effect models are probably one of the unsolved issues so far, and it's very difficult. It's very important to understand that this is your indication of an effect size. And yeah, you can convert this to percentages if you want. But yeah, this is basically the important indication. So yeah, and the correlation of fixed effects is interesting if they are highly correlated. So I assume for a lot of social psychology experiments, this is very important. Yeah, or for many other data. So if some factors are almost perfectly correlated with each other, then this is something maybe to worry about, because the variance explained is not unique. So yeah, I hope this is about it. Still, if you have questions and things are unclear, hit me up. And good luck with playing around yourself a bit. So, okay. So.